All right, hello and welcome to SUSECON Digital. As the title suggests, the focus of this talk is around testing software-defined infrastructure or infrastructure as code. A quick overview of my background. I'm a developer on the public cloud team at SUSE. Prior to joining SUSE, I had a background as a Python developer across many different tech stacks. Recently, my focus has been on building an automated CI/CD pipeline for uploading, testing, publishing public cloud images. It's in this development where I've come across the tools and the techniques which we will discuss in this presentation. So we'll get started and review the agenda. In the first section, I'll explain what IAC or infrastructure as code and configuration management are, and also what the similarities and differences are. The second piece, I'll do a quick overview of test-driven development. Here I will correlate the advantages of TDD in relation to infrastructure as code. And finally, we'll do a quick walkthrough of a few code examples and finish up with closing thoughts. So first, we'll do an overview of IAC and config management. As a note, I think these terms can be confusing. Sometimes they're used in different ways. My goal here is to clarify how I'll use them and also try to define how they are different or similar. So we'll start with configuration management. Configuration management is the practice of handling changes systematically so that a system maintains its integrity over time. My take on config management is that it's any process that is used to set up, configure, maintain, track, or update a product during its life cycle. This could be with a bash script, Python scripts, configuration management tools, etc. Configuration management tools essentially bootstrap and initialize resources. So we're talking files, users, groups, permissions, and also they are used to install and manage software packages on a machine that already exists. I think the last point is key here. So when comparing this to infrastructure as code, config management is mainly focused on provisioning or managing the resources on a running instance, whereas infrastructure as code is focused on the underlying infrastructure. So what's necessary to actually get that instance up and running. As far as existing tools to choose from, there's many examples. Ansible, Salt, Chef, Puppet are a few, and with this talk, we'll focus on Salt. Salt is an open source Python-based tool for event-driven IT automation, remote task execution, and config management. It uses state files, which are YAML format, to define the configuration, and these can be considered also as definition files as they define the expected state of a system. So we have an high-level overview of config management. Where does the infrastructure as code fit in? Infrastructure as code is a process of building, changing, and versioning infrastructure. The target here is the provisioning step for things like instances, containers, serverless functions, storage, networking, databases, and etc. Again, you're creating definition files or config files, or also they might be called plans that define the infrastructure necessary for a given app or a data center. An example could be using IAC to provision an EC2 instance, a database, and the networking to run a given app. Then config management is used or can be used to configure the instance once it's running. So that's the package file, packages, config files, and users, for example. As with config management, there's plenty of tools to choose from for this, or for the example code we'll go over. I chose to use Terraform. Terraform is, again, an open source infrastructure as code tool. It's created by HashiCorp, and it enables users to define and provision database infrastructure. I use Terraform to provision the example instance and the networking. And as a note, the main focus with the testing will actually be on the salt states, but both the infrastructure as code and the config management will be tested through the TDD tests. So why use these tools, these concepts in the first place? Some advantages: infrastructure as code can help you avoid mistakes by making things repeatable and easy to change. It can also save time, keep infrastructure consistent, and lower development costs. There's still a chance for mistakes to happen, but at least we're able to narrow the scope to where they're happening and hopefully narrow it to the types of mistakes that might happen. So long as your definition files live in version control, the history becomes fully visible, it's traceable. If any issues arise, they can be pinpointed. It allows you to test them, resolve them, test the fixes, make sure everything has been fixed. And this also allows you the ability to easily roll back. So if a issue is pushed out to production, you can roll it back and update all of the infrastructure rapidly. That being said, with any new tool or workflow, there's always going to be a new set of challenges. With IAC and config management, the issues and challenges can be duplicated. So this is called error replication. Basically, bad configuration can get duplicated across many instances. This could be clusters of hundreds or thousands of instances. This also until the issue is fixed in the definition files, the issue might be redeployed by accident. The second issue here is configuration drift. When a change is made directly to a server rather than a definition file, the server that's running no longer matches the definition files that we've used to configure that server. The final one I have here is erosion. This is more of a general issue with infrastructure, so it's not really tied to infrastructure as a code, but it's something that it also doesn't solve. So you still have to be on the lookout for it. And this is caused by operating system or software updates, patches, CVEs, processes or hardware crashes, etc. And it's something that, something that automated infrastructure doesn't resolve. This last one. So this is only a snapshot of the issues and challenges that may arise. I highlighted these specific issues mainly because we'll circle back to them in the example code, where we'll get to see some of the issues that can arise when you're writing these tests. So we covered the infrastructure tools, and we can move on to testing and test-driven development. So one thing as a precursor to test-driven development, there are many different testing methodologies, and all have advantages and disadvantages. Test-driven development is popular, and it's a powerful option that can, say, have a steep learning curve. Generally, with more development experience, TDD can become easier to implement. However, even though it does have a steep learning curve, I think for testing infrastructure, even someone with less experience can implement a test suite. The infrastructure tests are relatively simple and straightforward, and none of them use any complicated programming techniques or software techniques. So I think it can be accomplished with a short ramp-up period. TDD itself is a process where you write a suite of tests to cover your requirements before actually moving on to development. So in the case of infrastructure as a code, you write the suite of tests that confirms the state of your infrastructure, Once the suite is finished, all tests are run against an empty infrastructure. You can confirm that tests fail. Most of the tests should fail. Some of them might actually pass if the infrastructure already has, say, a package installed by default. Then that test will pass. And then you run through and iterate on basically 2 steps. So you'll implement a feature. So in our case, we'll implement a new salt state. For a feature, we'll run the tests, confirm that the tests pass for that specific feature, and then iterate until you have all the tests passing. So what advantage does this give you doing test-driven development on infrastructure as code? Using the test-driven development methodology for IAC can lead to more modular and flexible and extensible definition files. By writing the tests first, it helps you visualize all the distinct requirements and organize them as separate states rather than one big state file. This makes configuration easier to change and easier to reuse. For example, you may have a requirement on the Apache 2 package. If this is a separate state, it can then be reused for any server in your infrastructure, and it also can be easily replaced by, say, an Nginx state if you choose to pivot to a different tech stack. TDD provides very fast feedback when something breaks, especially when it's tied to an automated CI/CD pipeline. So if something is broken or if a change breaks something, it can be caught pretty quickly in the testing phase. And it also prevents the issue from making it into production. It can help prevent unnecessary config or states, and it keeps things simple. So for instance, your system may already have a needed package installed. This will be visible on the first test run, and it means that you don't have to create the extra state. For example, the code that we'll go over later, the instance that I'm using by default has Python 3 installed. So instead of writing that state, that test passed right away. Having the states in place from the beginning also means there's always some sort of documentation to reference. This isn't real documentation per se, but it could be helpful for anyone who has more of a development background, where a sysadmin or a DevOps engineer might find just reading the salt states easier. A developer might find reading the tests easier to understand. So it kind of gives you an extra layer of visibility into the infrastructure, into what's being defined. The inclusion of the tests will generally be driven using a CI/CD pipeline, which then helps make smaller changes more rapidly. If things are being continually tested, there's less concern of breakage. If you make a quick change, it breaks something in your infrastructure, you catch it quickly, you catch it before it goes into production. And this gives you more confidence to do rapid development, make smaller changes more quickly, and track those changes, which allows you to roll back if something does slip through the cracks. In the end, having tests in place and using a CI/CD pipeline can provide peace of mind that your IAC config management workflow is in good shape, and you have visibility and rapid feedback when changes are made, which can help catch errors before they hit production. So we'll move to the example tests, which I chose to use the Pytest package. PiTest is a popular Python-based testing tool because Python is considered an easy language to learn and it has easy syntax. I think it's a good choice here for this use case. I understand that the talk covers two different areas. There's generally the development side, and there's the system administration or DevOps side, but I think Python lowers the barrier here to where someone with less development background could write and run a TDD test suite for their infrastructure. And on top of that, the tests themselves are very simple, so there's not a heavy usage of complex programming concepts. And then the final reason to use PiTest is it has a rich plugin in architecture, and this includes the test infra package, which we'll use for actually writing the infrastructure tests. Test Infra is a plugin to Pytest, and it provides a fixture and modules for testing infrastructure. The fixture is a wrapper around testing things like files, interfaces, packages, services, sockets, system control, system info, users, and many other options. One nice thing is it obfuscates the underlying operating system, so it makes writing these tests very simple, and they're pretty generic, not really tied to a specific operating system. It also provides some backend plugins to access the instances and actually run the tests. And a few of those are SSH, Salt, Ansible, Docker, and kube control. So we will move on to the good stuff. For the example, I'm using Terraform to provision the instance in EC2, along with the networking to be able to have access to that instance. And the plan is using a remote executioner to install Salt, run the states on the instance in a masterless configuration, and then it runs test infra locally against that server to actually run the tests and confirm the state of the server. And again, as a note, the tests themselves are more focused on testing the configuration management states, so the Salt states, but also passively test Terraform, that the instance is up and running, that it's accessible, which is the infrastructure as code side. So it's able to test both. So the example itself is Python 3 Flask API. The API will be served with Apache 2, and it's using the ModWSGI plugin. And it's running on EC2 and a Leap instance, OpenSUSE Leap instance. And for the API, it will provide an interface for creating, updating, deleting, and listing types of pancakes. All right, so we switched over to the code examples. I'm going to run through these pretty quickly, just to give an idea of how easy it is to actually write these tests using Python, using PyTest. So based on the example we just discussed, the first few, we want to make sure that we have a user running for the app that's going to be provisioned. So here you can see that we're checking the host system. Does it have the user pancake? And is that user's home directory set to var_lib pancake? So again, this is a pretty simple test. It's pretty straightforward. Next one, ensuring the packages are on the instance. Here's a nice thing that PyTest adds is the ability to parameterize tests. So we're able to reuse this code multiple times to check each of these packages. So we know we want Apache running, we want the ModWSGI plugin, we're going to want Git to pull in the code itself, and then Python 3 and the Flask package to actually run the app. The next one is the Apache Service itself. So we know that the Apache package is installed. Now we want to make sure the service is running. So again, here, all we're doing is getting the service. We're seeing service is running, service is enabled. Once we know everything's installed and enabled, we want to make sure we have the configuration files provisioned. So here we're using the parameterize function again to run this test 3 different times to check that the WSGI file gets installed, the configuration, and then the JSON file, which is essentially the static database for this app. So here using the file module from test infra, and we're checking, does the file exist? And if it exists on the drive, is it actually a file rather than a directory? And then make sure it's owned by the Pancake user, which has a group with the same name, and that the permissions are set accordingly. So to get the code itself, we have a test here for the Git directory. So I want to make sure that the base user, so EC2 user, is the base user for an OpenSUSE Leap image. And we'll put the code there, make sure it is a directory, it exists. So similar kind of syntax, but this time for a directory. The user, we want the main root user to own this, and by default, the OpenSUSE users have a group users. And here we want the mode or the permissions to be 755. And here's the one of the tests for the actual infrastructure as code. So all the other ones were mainly focused on the config management. So here we're confirming that the instance OS name matches what we expect. So we want OpenSUSE Leap 15.1 matches the pretty name in the etc OS release file. And one thing I wanted to point out here is the PiTest fixtures, which is how you are able to reuse code in PiTest modules. So here I have a function to get the release value from the OS release file, and that way if I want to use it in any follow-on tests, then I'm able to essentially import it, use it, and that's how I'm able to check the release name matches what's expected. The final test is the endpoints. So this is testing that the app that we installed is actually running, it's accessible, and we can ping the API and get the expected responses. So here we're doing basically just a command run. We're curling the local host that the app is running, and in the standard output we should get the default types of bananas. And we do the same thing for the other API interfaces. So getting a specific type, doing the delete, and doing a create. So that's basically what I wanted to get through for this part of the presentation, just to point out how I think it's relatively easy to write these tests for infrastructure as code, even if you're maybe not a developer or if you don't have a lot of experience in Python, for example. They're pretty simple, pretty straightforward. So now that I went through a few code examples just to get an idea of how you would use PiTest, how you could use that to test configuration management states and infrastructure as code. So a few closing thoughts. What I hope you can take home from this presentation is that it's easier than you think to test IAC and configuration management, whether you use TDD, test-driven development, or some other testing methodology. I think the benefits that are gained are certainly worth the effort. Finally, by taking the steps towards software-defined infrastructure and driving development with a CI/CD pipeline, I think you can simplify, accelerate, and modernize your IT environment. In the end, this means better scalability, more efficiency, lower costs, and a faster mean time to recovery. So I have the links to the code examples and also the example project on GitHub. So this will be available in the presentation. And that's all. Thank you for giving me the opportunity to speak, and I hope you enjoy the rest of SUSECON Digital.